here's what we're going to look at. Last type of problem. We need to be able to match. Yes. Yeah. All I know is I take the thing out of here, I stick it in the computer, put it on YouTube, and then it just goes there.
Is it recording subscribers?
It's what?
Do you have subscribers?
Who?
Do you have YouTube subscribers?
No. Okay.
IT blog.
Oh my gosh. Okay. Can we? This is supposed to take 2 minutes. We're already like, oh my gosh. Okay. We need to do some matching again. We need to match those things with these slope fields. This is different than pages 2 and 3. Flip back to pages 2 and 3 and tell me what looks different. Raise your hand and tell me what is different about these versus pages 2 and 3. I find it very hard to believe only 4 people are seeing differences. Adish.
So in pages 2 and 3, it was labeled as dy dx is equal to something, but in this, it is only y is equal to something.
Okay. These are not, at the top of the page, those are not differential equations. These are possible solutions to differential equations. I've got no clue what the differential equations actually are. I want to figure out, for these solutions, what slope field might match up with their differential equations. Here's how we're going to go about doing this. Y equals 1. You know what that looks like. What does that look like?
Horizontal. Vertical line. Vertical. Horizontal. I was right the first time. No, horizontal. I was right.
Y equals 1 is a horizontal line at a height of 1. Okay, now we're going to focus. Oh, good. So here's how we do this. Y equals 1, you know what that looks like. Can I fit that horizontal line on top of any of these slope fields? James, which one? D. I could draw that horizontal line y equals 1 over there. 15 is going to get matched with D. That's how we do this. And these are all kind of based on those 20-some graphs that I gave you over the summer of things we need to know what they look like. Y equals x, you know what that looks like. Line with a slope of 1. Can you fit that on top of any slope field here? H. I would like you to take a moment, do the rest, using what you know about, in general, what those graphs look like. And at some point, you might just start using process of elimination. While this is happening, I'm going to pass out the homework, and I'm going to pass out the chapter review and your cumulative review. Although there is one more thing I want to do after this, so don't pack up yet. No, go work.
I just want to know. That's it.
I shouldn't have said anything. I should just push the button. Noticed.
Probably not.
Okay, go work. Go work.
I don't know what these guys
Do what you can, and we'll match things in a moment.
This is preposterous. I can't get it. It's really long.
You should know what a parabola looks like. You should know what a cubic function looks like. You should know what a sine looks like. You should know what a cosine looks like. You should know what a natural log looks like. We'll talk in a moment.
Wait, this is it?
We're done. I feel like I said that 5 or 6 times already. Okay, you're still matching. Keep matching. So I'm giving you the review packet right now for the test, because when we come back, review day is Monday and our test is Wednesday. Do not go home and do the review packet tonight. That's not going to be helpful for you for reviewing for the test. If you do want to look at it during break, which might not be a bad plan, wait till the end of break, then start looking at a couple things. I will get my work online at some point. Probably later today. Oh, that was one of those 20-some graphs that I gave you over the summer.
You don't know what one of our axes is.
Okay, just work. Just work. Just work.
Yes, I think I have to do that because I just have to end up erasing all my answers.
Okay, so let's keep matching things.
Me too.
But number 22 is not the natural log of x. All right, 17. Sophie, what did you say for 17? So we're basically saying, where can we fit a parabola? Sure, I can fit a normal-looking parabola in letter C. 17 is going to be C. I think you should know what x cubed looks like. Forget about the 1/6. That really doesn't affect things. But, Lizzie, what did you say for 18? F? Sure, because a cubic function looks kind of like one of those things. And yes, in F, I can fit that on my slope field. 18 is going to be F. Fine, we'll skip 19 for right now. 20 versus 21. Paulina.
For sine at 0, it should be 0, so it's like the same graph, but and then for cosine, it's a little bit shifted, so it starts at 1, and then it's like a loop up and down.
And then it's a what? Of course it is. Oh, good. So 20 is what letter?
I got
Okay. And 21? B. Okay. The natural log of x. You know what the graph of the natural log of x looks like, I hope, because we just did a unit on that. Natural log of x should look like this. What does the absolute value do to the graph? James. Gives you the other side as well. That was kind of why we talked about the derivative of the natural log of the absolute value of x is the same as the, well, whatever. Where can we fit that? Summer. Oh, okay, so let me try. I've got 1, 0. I've got e, comma 1. Yeah, I can definitely fit that shape over there. So that one's going to be G. And by the process of elimination, 19 is going to be A, but that was one of those graphs that I gave you over the summer that looks something like this, with a vertical asymptote at x equals 0, 2 branches going up, horizontal asymptote at y equals 0, and I feel like that I could fit that on top of that, and things kind of work. So yeah, we do need to know what basic graphs look like. No, I won't make you match things like e to the x squared minus 4 over natural. I won't give you complicated things, but we should know what the basic things look like. Questions here on this stuff? Dr. Yes? Okay. So the same reason that, please don't pack up because there's more we're going to do. The same reason that there's lines everywhere else with all the other things. I'm asking you, y equals 1 is one possible solution to that differential equation. There are other possible solutions, y equals 2, y equals 5, and I can't give you y equals 1, y equals 2, y equals 3 and ask you which that's going to match up with, because they're all going to match up with that same slope field. And actually the reason for that is all those things would have a slope of 0. I'm looking for a slope field where the slope is 0 absolutely everywhere. That's what this slope field looks like. But there's no way to distinguish between y equals 1 and y equals 3 for something like that. Other questions here? Okay, so I'm not going to turn this off like I did yesterday. I'm going to just push this.